On Friday, I showed you how to determine the empirical formula, the simplest formula. For some molecules, we know that the simplest formula doesn't tell the whole story, and some molecules are made up of more than one chunk of that simplest formula. In order to determine the formula of an actual molecule, we need the empirical formula and its mass, and the second thing we need is the molar mass. And with those two pieces of equipment, I was going to say, those two numbers, pieces of information, we can then determine what the overall molecule is like. Now, you guys, when you determine the molar mass, you actually need the formula to do it. You put the arrows underneath it, you do your calculations, right? You can actually experimentally determine the molar mass as well. Now, I'm not going to teach you here on how you do that. We will actually learn how to do that in the last unit when we get to gases. But it's really easier than you think. I'll pause for writing. So you don't have to write this little bit down, but I just want to get across to you that we can get the empirical formula from experiment. That's what empirical stands for, right? It means experimental. If we start with percentages, we go through all those steps of determining the number of moles. I'll do another example with you. You'll all kind of go, oh yeah, I remember how to do that. But then we need the molar mass, and the molar mass can also be determined from experiment. We get the molar mass from our formula. That would be a theoretical molar mass. That would be what we believe the molar mass to be if we assume all these masses to be correct. And they are, by theory. But remember, molar mass has the units, and you don't have to write this down, it has the units of grams per mole. And so if I, in some way, in an experiment, could determine the mass of a substance and determine how many moles of that substance I have, I could put it in an equation like that, and I would get a molar mass. It would have nothing to do with the atoms and the masses on the periodic table. It would simply be an experimental measurement of the mass, put it on a scale, and then somehow an experimental measurement of the number of moles. The easiest way to do that is with gases, and I can't show you that right now because I haven't taught you about gases yet. But when we get to the gases unit, you will be able to experimentally determine the number of moles of a substance without using the molar mass and conversion factors. So this can be determined experimentally. I'm not going to make you do that here. I'm simply going to give you what they would have found experimentally, and we're just going to use it. But it can be determined experimentally. What that means is the entire molecular formula can be determined experimentally from our empirical formula experiment and then from a molar mass. Let me do two examples and then I'll let you work. EF stands for empirical formula. Now, this first example is the easiest of easiest examples when it comes to determining molecular formula. In an overall molecular formula problem, we would go through an empirical formula problem, use the percentages, convert them to grams, convert them to moles, divide by the smallest number, remember all that good stuff? Figure out what that smallest whole number ratio is, and then do this. So to determine a molecular formula, we're actually just adding a simple calculation onto what we already know how to do. In this example, I am showing you the little add-on calculation. In the second example, we'll do both steps. So in this example, let's say we've done all of our calculations, and we get to the bottom of the question, and we write down, therefore, the empirical formula is HO. We got a 1-to-1 when we divided off those numbers, right? Remember doing that? We'll do another example to get our brains back into it. We're told that the molar mass is 34.0 grams per mole. We need to figure out how many of these empirical formula pieces fit in the entire molecule. The way we do that is we get the mass of our empirical formula. You already got it? 17. Excellent. 16.0 plus 1.0, that's 17.0 grams per mole, and I'm going to give that a title called the empirical formula mass, because it's not necessarily the mass of the molecule, not the molar mass. It's just the mass of a small chunk. I now need to figure out how many pieces of this fit into the entire molecule. Well, we don't need to do a calculation for that. Well, can you tell me how many pieces of HO fit into the entire mass of this molecule? 2. Now, sometimes it's not so clear, so we should write a calculation down. To determine this, we simply take the molar mass, which is going to always be the bigger number, divide it by the empirical formula mass, in this case, 34.0 grams per mole divided by 17.0 grams per mole. And that gets us 2. What that means is this molecule is actually made up of 2 units of HO, which means now we can say the molecular formula. Therefore, the molecular formula is, well, what is it? If it's got 2 units of HO, what's the formula going to be? Yep, Jennifer? H2O2. H2O2. That's a pretty simple step. When we're given the molecular mass, we're going to figure out the mass of the empirical formula. We're going to find the ratio. Whatever that is, we're going to multiply the empirical formula by, and we're going to have the molecule. One important thing. At this spot right here, very important, so I'll put a couple of exclamation marks. No decimals here. Remember at the last step when we were doing our empirical formulas, if we had a 0.5, what did we do to fix that? We doubled it. 0.33, we tripled it. When you do this extra step on the end, you cannot have a 0.5 or a 0.33. It must be a whole number, because it's going to tell us how many of these individual units my molecule contains, and it can't have a half of a unit. So if you get a decimal there on the test when doing the last step to determine a molecular formula, you've done something wrong. You got to go back and look for a problem. I'll tell you now, if you get to the test and you get a decimal there and you're panicking because there's time ticking away and you cannot find it, then break the rule and write 2.5, 2.5. Because then at least I'll be able to give you marks for following through on what you did. So if you can't find the mistake, make it look like an ugly formula, and I'll be able to give you marks for that last step, okay? But if you can go back and find it, that's the best way. Let's do one more example, and this time, this example is going to be right from the start. So I'm giving you percentages. We're going to have to figure out the empirical formula. I've given you a molar mass, and now we just tag on that extra step. So I know this was, not just 2 days ago because there was a weekend in the middle. So we're a handful of days ago. But if I'm starting with carbon and it's 81.8%, what do I do first? Yep. Assume it's 100 grams. You don't need to write that step down, but that's where we're going to write down our 81.8 grams. Then the molar mass to turn it into moles. Then the smallest number, divide by that smallest number. So this is essentially our empirical formula determination steps. $81.8 grams. And the hydrogen is what? The rest of it? Hydrogen is 18.2 grams. I need the molar masses for those two elements so I can figure out the moles of the elements. You've already got numbers? Oh man, Brody is on fire. Half the class is still pulling out a periodic table. Even though we use carbon so much, we should know what that is. Molar mass of carbon without even looking. 12. And I really hope we didn't look for hydrogen. 1 mole, 12.0 grams. 1 mole, 1.0 grams. I've paused sufficiently. Brody, what do you have for numbers? 6.82 moles. 18.2 moles. You'll notice we've got bigger numbers this time. That's okay. It doesn't matter what the size of the numbers are, whether they're decimals or you've already divided as well. Oh man, Brody, slow down. Let me write it down here. 6.82 divided by 6.82. I got that one. That's 1. 18.2 divided by 6.82. And Brody is just itching to tell me what he got. Ooh, 2.66. That's fun. We haven't had a 0.66. What am I doing to get rid of that 0.66? We better ask someone else. Maggie, what do you got? I'm going to do a multiply by 3 times 3. It's going to get me 3 times 3. What does that get you? Yep, Brody. 8? 8. Beauty. So our empirical formula is C3H8. That's the simplest. Now I'm going to do the step that I just taught you. Find the mass of that thing, divide the molar mass from the empirical formula mass, see how many chunks fit into that particular thing, and then we multiply. And we've got it. So what did I teach you today? I taught you how to divide a couple of numbers to get a whole number and then just multiply your molecule by it. Very straightforward. 8 times 1.0, 3 times 12.0. What is that? Yeah, Chelsea. 44.0 grams per mole. That is the empirical formula mass. Yeah, maybe we should put some labels on here just so that we know what we're looking at. Always the big mass over the small one because we need a whole number. Molar mass over the empirical formula mass. 132.0, 44. We're hoping for a whole number. Yeah, Chelsea, what do you got? 3. Therefore, the molecular formula is, take all of our subscripts in the empirical formula and triple them. What is that? C9? C9H24? 24? 24. That's how you determine a molecular formula from an empirical formula. Last little step that goes on it. So at this point, there are some textbook practice problems. And that says page 193 under that, that little MF there. All right, so at this point, I don't care what you work on. If you'd like to work at home on the lab, or you've started on the lab and you've got questions for me, or all that kind of good stuff. But I really would like the lab tomorrow because it would allow me to get some marking ahead on the weekend. Yep. Yep. And I'm going to just shut this recorder off for a second.